Hello all, my name is Shravan and this is my ELL101 project. In the project, I have studied about the operational amplifier and made its application as a relaxation oscillator. The components used in the circuit are op amps, resistors and capacitors. Here are the following electronic devices: the resistors, the capacitors and op amps. So what is an op amp? This is an 8-pin IC integrated circuit with IC number 741. In the following op amp, the pin 4 acts as a negative terminal. The pin 7 acts as a positive terminal for biased voltages, and the pin 2 and pin 3 acts as inverting and non-inverting input terminals respectively. Op amp as a relaxation oscillator. What is a relaxation oscillator? This is the question. So, a relaxation oscillator is defined as a non-linear electronic oscillator circuit that can generate a non-sinusoidal repetitive output signal. In our case, we are discussing a square wave signal, repetitive. The design of relaxation oscillator must include non-linear elements like transistor, op amps or MOSFET. In our case, we have used op amps, and energy storing devices like capacitors or inductors. In our case, we have used capacitors instead of inductors. So, this is the following circuit of an op amp. An op amp relaxation oscillator is also known as a stable multivibrator. It is used to generate square waves in our case. So this is a capacitor, these are resistors, and here is a op amp. How does it work? The non-inverting terminal of an op amp is connected with an RC circuit. So the capacitor voltage VC is same as voltage at non-inverting terminal V minus of op amp, and the inverting terminal is connected with resistors. When V plus is greater than V minus, the output voltage is plus 12 volts, and when V minus is greater than V plus, the output voltage is minus 12 volts. The voltage at inverting terminal is B times V input inverting, where B is equals to R2 over R2 plus R1. In the following case, where we have taken plus 12, this is when B is equals to 0.5 and the input voltage given is 6 volts. Therefore, 6 upon 0.5 is equal to 12, which is the V output. For instance, taking R1 is equal to R2, the B is equals to 0.5 in our case. Then in this condition, V plus is greater than V minus. So output voltage V out is equals to plus 12 and the capacitor starts charging. When the capacitor voltage is greater than 6 volts, V minus is greater than V plus. Hence the output voltage changes to minus 12. During this condition, the inverting terminal voltages changes its polarity. So V plus changes to minus 6 volts. Now the capacitor discharges up to minus 6 volts. When the capacitor voltage is less than minus 6 volt, again V plus is greater than V minus. Therefore, again the output voltage changes itself from minus 12 volts to 1 plus 12 volt, like done before. The capacitor now starts charging. So this process continues and forms a square wave form of plus 12 and minus 12 as the output voltages. So the charging and discharging cycle of capacitor generates a periodic and repetitive square wave at the output terminal as shown in the figure below. So here, the V output is plus 12, then it becomes minus 12, then again plus 12 and minus 12 respectively. So this shows a square wave repetitive form of which oscillates between plus and minus 12. And we can see B times V out, which is equal to the V input we are giving in inverting terminal, which is plus 6 volts and minus 6 volts respectively. So this shows a square wave form. Relaxation oscillator frequency. The frequency of relaxation oscillator depends on charging and discharging time of capacitor. In RC circuit, the charging and discharging time decided by the time constant. In op amp relaxation oscillator, the R1 and C1 contribute to frequency of oscillator. As we have seen, the R2 and R3 contribute to the beta factor, and R1 and C1 contribute to the frequency. Therefore, for a lower frequency oscillation, we need a longer time to charging and discharging the capacitor. And for a long time of charging and discharging, we need to set a more significant R and C. Similarly, a small value of R1 and C1 causes high frequency oscillations. Therefore, the oscillation frequency depends on value of R1, R2, R3 and C. An op amp relaxation oscillator frequency formula is 1 over 2 times R1 C1 times ln1 plus k over 1 minus k. K is nothing but beta, which is equal to R2 over R2 plus R3. In most conditions, R2 and R3 are same to make easy calculation and design. So the beta now becomes 0.5 and R2 and R3 becomes same. By putting value of R1 and C1, since we know what K is, we can find the oscillation frequency of the op amp relaxation oscillator. This was my project. Thank you for watching.